Welcome to AI Podcast. Today we're talking about a neat idea from AAAI 2025 called QAagent.
Give me the quick version first. What's the headline?
Two language model agents team up. One writes natural language pseudocode that explains how a function should behave, and the other uses that plan to generate unit tests. The upshot is higher test coverage than several well-known baselines, while accuracy is strong on some tasks and noticeably weaker on others.
So the system thinks before it tests. I like that. Who's behind it?
Lead author Akhil Deo from Johns Hopkins University. It appears as a student abstract at AAAI.
Got it. Set the stage for me. What problem in testing are they tackling?
A big one. LLMs can already write code and tests, but the tests are often flaky, shallow, or tied to the code they see. Many approaches jump straight into writing assertions without a clear model of the intended behavior, which can miss edge cases or even check the wrong thing.
Right, like writing a quiz without really knowing the lesson plan?
Exactly. QAagent flips that. It first asks, what should this function do, step by step, in plain language? Then, based on that explanation, it writes tests.
Walk me through the two agents in everyday terms.
Picture a construction project. The first agent is the architect that sketches a clear blueprint in plain language. The second agent is the building inspector who walks around with the checklist and says, let's verify each beam, each door, each emergency exit. The blueprint comes first, then the inspections.
Makes sense. What does the pseudocode actually look like?
Think recipe. If the function is supposed to validate an email address, the pseudocode might say, check there is an @ sign, confirm the domain has a dot, reject leading or trailing spaces, handle unusual but valid cases. That list becomes the basis for tests that hit typical and edge scenarios.
And this is done without seeing the actual implementation, right?
Right. The agent gets the function signature and a short description, then it infers the intended behavior and writes tests from that.
How is this different from popular multi-agent frameworks we hear about?
Many frameworks focus on generating code and then iterating on it with tests. QAagent is narrower and more pointed. It says, let's model behavior first in words, then write tests. That separation is the key bet.
Cool. What did they use to evaluate the idea?
Two standard coding benchmarks, Human Evil and MBPP. Even though they're known for code generation, you can repurpose the problems to judge test generation. The team compares QAagent to direct prompting and a couple of well-known multi-agent baselines.
Remind folks what those benchmarks are in simple terms.
Human Evil is a curated set of Python function tasks. MBPP is a larger collection of beginner-friendly Python problems that cover a wider variety of everyday tasks. Human Evil is tight and clean. MBPP is broader, which can challenge assumptions.
And the metrics they care about are coverage and accuracy. Can you translate those for the hallway conversation?
Sure. Coverage is how much of the target code your tests actually exercise. Accuracy is whether your tests are checking the right behavior and producing correct pass-fail judgments. High coverage feels great, but it does not guarantee the tests are meaningful.
Right, you can flip every switch in the house and still miss that the smoke detector is broken.
Perfect analogy.
So how did QAagent do?
In short, coverage improved a lot compared with the baselines. Accuracy is mixed. On Human Evil, it looks strong. On MBPP, it drops noticeably. That pattern suggests the pseudocode-first strategy is very good at exploring the space of behaviors, but translating that exploration into correct assertions is harder when tasks get more diverse or ambiguous.
Why would MBPP be tougher?
Because the agent is inferring behavior from sparse hints. If the pseudocode quietly misunderstands a requirement, the resulting tests will confidently check the wrong thing. MBPP has more everyday data wrangling and corner cases, which increases the chance of that drift.
So coverage tells us the tests go many places, but accuracy tells us whether they look in the right places for the right reasons.
Exactly.
Any details about models or prompts we should keep in mind?
The comparisons involve strong language models. That's helpful, but it also means results can be sensitive to model choice and prompt phrasing. The abstract format is short, so some nuts and bolts like exact coverage instrumentation, random seeds, or how many runs were averaged are not fully spelled out.
Which brings us to reproducibility. Did they give enough for someone to rerun the study cleanly?
For a student abstract, it is a solid start, but more detail would help. Clear definitions of coverage and accuracy, multiple runs, and open prompts would make the picture stronger. Also, the baselines mix frameworks and models, so the fairest comparison would hold the model constant across methods and give each method the same budget.
And the benchmarks themselves are tiny functions. Real projects have fixtures, state, and weird dependencies. Any thoughts on that gap?
That's a big next step. It would be great to see QAagent tested on multi-file repositories with mocks and databases and all the messy reality. Also, measuring flakiness and bug-finding power, not just coverage, would tell us whether these tests actually protect a codebase over time.
Let's talk about the underlying insight. Do you buy the idea that pseudocode first is the right mental move?
I do. Humans do this instinctively. Before writing tests, a good engineer writes down what success looks like, what failure looks like, and the edge cases. Baking that into the agent workflow feels like a strong design pattern.
If a team wanted to try this tomorrow, what is the lowest effort pilot?
Ask developers to jot a short natural language blueprint for each new function. 1 or 2 paragraphs tops. Feed that to a model that generates tests. Then do a human review focused on assertion quality and false positives. Track 2 practical metrics over a sprint or 2. How many real bugs did the test catch, and how often did they flake?
Nice. What about strengthening QAagent itself?
A few ideas. Add property-based testing so the agent generates tons of varied inputs, not just hand-picked ones. Pair the pseudocode with static analysis or type checks to catch obvious mismatches. Run ablations. For example, test with and without the pseudocode step to quantify its contribution. And expand beyond Python to see if the idea generalizes.
I'm also curious about having a third agent that critiques the pseudocode before any tests are written. Kind of a devil's advocate that asks, are we missing a boundary? Are we overfitting to the happy path?
I like that. Even a simple consistency check could prevent the classic error where tests confidently enforce a misread requirement.
Let's circle back to the author for a second. Student abstract means it is early stage, but the core idea is pretty clear.
Right. Credit again to Akhil Deo and the team context at Johns Hopkins. The contribution here is a clean separation of roles. First, reason about behavior in plain language, then translate that into tests.
Give me the bottom line. If you had to summarize for a busy engineering manager driving between meetings, what would you say?
Pseudocode first test generation is a promising pattern. It reliably boosts coverage by forcing deliberate reasoning about behavior. Accuracy still needs work on more diverse tasks, so keep a human in the loop and evaluate on your own code. But as a workflow idea, it is absolutely worth piloting.
Right, think blueprint, then inspection, not inspection without a plan.
Exactly.
Any parting cautions?
2. Do not treat coverage as a victory lap. Pair it with checks for sound assertions and low flakiness. And when comparing tools, hold models and budgets constant so you are comparing methods, not compute.
Great. Quick takeaway for listeners.
QAagent reminds us that language is a great place to think. If you can explain the behavior clearly in words, your tests have a better shot at being thorough and useful. Plan first, test second, verify always.
Nicely put. That's our show from AI Podcast. If you try a pseudocode first pilot, tell us how it goes.
Thanks for listening. Until next time.